Start another recording. So let's try this again. Second attempt. Right click and set a breakpoint. Insert breakpoint. Okay. Now try to run it in debug mode. Start debugging. Oh, I never built this, so let's build real quick. We built this. Okay. And we run it. Debug, start debugging. You know, I'm using the menu to make it simple. So we expect this, of course, to go right here, right? So if I say F11, I guess would be step into F11. Yes, that's exactly where I'm going. Function does nothing, but I still make a call. Next line, print OK. The string literal returns a pointer to the first character, so I'm going to go into this one. And finally, I come out of it, press F11. I just keep pressing F11 to do each step. And this, okay, so that's done. So, and this last call brings us to int, and not as someone might be expecting to make a call with a pointer. So more on this later. So yes, indeed, it works, and you can see that it's happening. So it's another call to the version of print that uses an int parameter. So some concerns with function overloading, and you know, again, we will demonstrate later on many times how function overloading takes place and what happens, what gets compiled, what we can observe, what gets invoked. Okay, let me see what's going on. Oh, we're still debugging, so I'm just going to say debug, stop debugging. What else? Next topic is going to be our access control. Now, the good thing is that you don't have to memorize all of this, but as your experience grows and you experience some situations where potentially the wrong function is called, remember that it may be an issue related to overloaded function calls, and also it may be an issue, maybe you get a compiler error. You're trying to, you know, you're being asked to modify some code, you create a new function, or maybe you're trying to change signatures of some functions, and suddenly you get strange errors that the code doesn't compile because there's like function overloading resolution fails on you. So clearly, you need to basically then examine each version of the function that you have, and then you have to make a decision what change to make, and how to make it compile, and how to make the compiler happy. Okay, so most of what we talk about today is quite a bit of those technicalities. Moving on, next item on the agenda. Encapsulation means that we want to restrict use of a chosen interface. For example, right here in the point class, I may want to restrict access to X and Y, because remember, X and Y truly is instantiated inside each object, and I may wish to take advantage of encapsulation rules and try to preserve these unique variables inside each instance of my point class, inside of each object. For this, I can, let me just minimize this. For this, I can say, well, you know what? I'm changing my mind. I want to have it private. And then I want my member functions to be public. Now notice this. It's a very typical and perhaps desired situation where your member variables are private and your member functions, at least those that you want to make public, are declared public. You can also have private member functions part of your implementation. But this is a very typical thing. In fact, it's so typical that you don't have to say this. By default, when you create a class, everything is private, unless you say you change it to public. It doesn't mean that those sections are fixed. You can then, you know, you can create another private section right here and declare more things over here that would be private. And then you can again go ahead and make it public section again and do more things that would be part of your class public interface. So anything that's public inside the class is viewed as your public interface. That includes even access to your member variables if those were originally, as they were, declared public. They become part of your public interface. But in this case, they now became private, and they're no longer part of the official public interface of our class. Okay, so let's save this, and I made this little change, right? I removed public from the top here, and so let me try to build. I guess, I don't know, once in a while we can clean and do a clean build like this. Okay, so what happens here, and we'll go directly to the compiler output, it says cannot access private variable. So I can no longer assign values to X. Right, so I cannot do this anymore. So this becomes an error, and perhaps what I need to do is somehow provide initialization, which would be a natural way of adding constructor to our class. But that's going to be the topic of later on. I hope today we can get to that. Oh well, let's stop this part.